All right, let's just dive right into this explainer. Today, we are going to build a complete, genuinely intuitive mental model of how modern artificial intelligence actually works, right from the ground up. If you've ever felt totally overwhelmed by all the jargon floating around, LLMs, parameters, tokens, inference, you are in exactly the right place. We are taking all the mystery out of it today. Because it's a question we've literally all asked ourselves, right? When you type a prompt into your favorite tool, does the system actually understand language? Is it thinking the way you and I do, or is something else entirely happening beneath the surface? Whether it's ChatGPT, Claude, Grok, or Gemini, millions of us are relying on these systems constantly for writing, coding, or just brainstorming. Yet, for the vast majority of users, the underlying mechanics remain a total black box. We just type, hit send, and wait for the magic. But here's the thing, it's not magic, it's math. So here's our roadmap for this explainer. We're covering the foundations of AI, taking a look inside large language models, breaking down how AI learns and predicts, exploring the massive AI infrastructure, and finally, diving into AI agents and the future. We'll start small and zoom all the way out. All right, part one, the foundations of AI, from inputs to machine learning. To really get AI, we kind of have to look at how we used to do things. In traditional programming, humans provide the inputs and we write the super strict rules. The computer, it just follows those rules to give you an output. If X happens, do Y. It's entirely rigid and completely dependent on human instruction. But machine learning completely flips that script. Instead of feeding the computer the rules, we give it the inputs and the desired outputs. And we basically say, hey, figure out the rules yourself. Think about a spam filter. We feed it millions of spam emails and normal emails, and it learns the underlying patterns entirely on its own to spot the junk. And to pull this off efficiently, we use what's called a neural network. Now, don't let the name fool you. It's not actually a biological brain. A better way to picture it is like a massive, complex city road system. Data flows through thousands of connected pathways. Every single connection has a numerical weight, which is basically a way of deciding which roads should get the most traffic, until the system finds the absolute best, most accurate route to the answer. Which brings us to part two. Inside large language models, deconstructing the engine. So let's break down what a large language model, or LLM, actually is. It's large because of all those billions of pathways, it processes language, and it's a model. But listen, this is probably the most important thing you'll take away today. An LLM is definitely not a database of facts. It is not a search engine looking things up in some digital encyclopedia. No, it is purely a mathematical engine, constantly predicting the very next piece of the puzzle, just one step at a time. And here's the kicker. AI doesn't even see whole words like we do. It uses tokenization. So a word like artificial gets chopped up into chunks: art, ific, and acial. We call these chunks tokens. Tokens are literally the fundamental building blocks of these language models. And hey, fun fact, this is exactly why your API bills and context limits are always measured in tokens and not words. Moving right along to part three, how AI learns and predicts, parameters and inference. To really grasp the sheer scale of this tech, you've got to understand that modern models contain hundreds of billions, sometimes over 400 billion of what we call parameters. Think of parameters as billions of tiny, adjustable knobs inside the model. These knobs encode all the statistical patterns the AI soaked up while reading through mountains of data during its training phase. So, how exactly do those billions of knobs get tuned to the right position? Well, through a massive training loop. Over months of crunching through huge data sets like books, articles, code, you name it, the model repeatedly guesses a missing token. Then it measures how wrong its guess was and slightly adjusts those parameters to do better next time. It repeats this loop trillions of times until those knobs are perfectly dialed in to predict human language. Once that massive training phase is done, the knobs get locked in. Then we shift gears into a phase called inference. Inference is what's happening every single time you hit enter on a prompt. The model takes your tokens, calculates the probabilities based on those locked-in parameters, and spits out a response. It's way faster and cheaper than training, but make no mistake, it still takes some serious computing muscle. Now, the real secret sauce of inference relies on a massive breakthrough called attention. Check out the sentence. The trophy doesn't fit in the suitcase because it is too large. Does the word it mean the trophy or the suitcase? I mean, we humans instinctively know it's the trophy, right? Well, the attention mechanism lets the AI figure this out too, by mathematically relating every single token to every other token in your prompt. That is how it perfectly grasps context and nuance.
All right, part 4, the AI infrastructure, powering the prediction engine.
Let's zoom out a bit. Today, the software ecosystem is pretty much split into two distinct, really exciting camps. On one side, we have closed models like GPT and Claude, hosted by big companies and accessed through their commercial APIs. But on the flip side, we've got open weight models like Llama, DeepSeek, and Mistral. For these, the actual parameter weights are freely out there. Developers can download them, tweak them, and, wildly enough, even run them entirely locally on consumer hardware.
But whether we're talking open or closed, training and running the absolute best models takes infrastructure on a scale that's frankly hard to wrap your head around. We're talking about massive AI data centers packed with thousands of interconnected GPUs, facilities so huge they need their own dedicated power substations, and miles of intensive liquid cooling plumbing just to keep the servers from literally melting. The sheer physical footprint and billions of dollars required to keep this prediction engine running is just staggering. And finally, part 5, AI agents and the future, beyond the chatbot. Look, an LLM sitting by itself is basically just a really smart autocomplete predicting tokens. But when you give that same LLM a persistent memory, the ability to plan, and access to outside tools, boom, it becomes an AI agent. These agents don't just chat with you. They actively search the live web, hook into APIs, and can even write and run their own code. They can take a massive goal, break it down, and just autonomously get real work done. It is an absolute game changer. So when you put it all together, this complete flow is the new mental model I want you to walk away with today. You start with a simple text prompt. That triggers an AI agent to form a plan. The agent passes tokens down to those massive data center GPUs for inference, and the resulting math flows all the way back up to trigger a real tangible action in the world. It's this beautiful, interconnected loop from your keyboard all the way down to the server cooling pipes. As we wrap up this explainer, I really want this to sink in. Understanding AI isn't just about learning some cool new tech trend. It's about fundamentally grasping the next major computing platform, one that's rapidly becoming as essential as the internet itself. You now know exactly what's going on under the hood. No magic, just incredible math. So I'll leave you with this. How are you going to adopt, both in your work and your life, now that you truly understand the engine driving the future?